All right. So for question A is the same as what I showed you before, where you would let A equals to 0.4 is the dot there,
So
and then
1 digit will be 10.
Yep.
A, yeah.
It'll be 4 point and then 4 with the dot. You do that subtraction.
Yeah.
Alright, so technically you would write it this way, 0.4 with the dot, and then when you do the subtraction, it will be 9a equals to 4, and so a would be 4 over 9. Right? If it's 2 dots, then that means this is 2 1 2 1 2 1.
Yeah.
You times it by 100. So I'll just show you another version, which is question C, the supposedly harder one, but the only difference is this. So if you go let 1000, let a equals to 1.285, repeat all of that. Have you seen this version before?
No.
No, it just means you start repeating from 2 and end repeating at 5. So it'll be 285, 285. But I think they would use the bar here. It's a bit easier to see. So 1000 A would be 1285.1285. Sorry, 0.285.
Yeah.
Right? And then when you subtract that, so when you subtract the value of A, which is, we can actually align that here, 285. Okay? When you subtract that, we get 999 A equals to 1284.
Yeah.
Okay? So A would be 1284 divided by 999. Do you think we can simplify this?
311. Yes, you can.
Yes, by
3.
3. Very good. And that would be, the top would be? It's easier than you think. Okay, here's the trick. Take this number, right? Let's put that over here. So in your mind, you think 1284 divided by 3, right?
Yeah.
You take the first, if it's the first digit, it's smaller than 3, so you can't divide it.
Yeah.
So you take the first 2 digits divided by 3,
4
is 4. Remainder? There's no remainder, right? And then you take the next digit, 8 divided by 3.
Cannot. 2 remainder 2.
2 remainder 2, yeah, so you write 2 here and you remember remainder 2, which means the next digit would be 4 and you add the remainder, it will become
6.
24. The remainder 2 actually combined with this as into a 2-digit number. So 24 divided by 3 is 8. So 428 over 333.
Oh, okay.
Okay, can we simplify that further?
6. No.
No, I don't think so. Right? Because the bottom is only 111, which is the prime number, and 3. Okay. So yeah, that's about it. Okay, so that's a little trick. Can you use that trick to, this is a bit of a side note, but divide by 2. Divide by 2. Can you divide this number by 2? Try.
600 million.
No, there's no point. So you take, there's no point trying to remember, like to see how many 100 million or whatever. The answer is 61728,945.
Oh.
Okay? It's really easy. You take 12, so you should look in this way, right? 12 and then 3 and then 4. Basically digit by digit, only the first one you take 2 digits, right?
Yeah.
So 12 divided by 2 is 6. 3 divided by 2 is 1, remainder 1. So that number, next number is 14. Yeah? Okay. When you divide it by 2, if there's a remainder, it will just 10 plus the next number. So 14 divided by 2 is 7. 5 divided by 2 is 2, remainder 1, so it will be 17 divided by 2 is 8. Right, remainder 1, 18 divided by 2 is 9, and then you can take 90 divided by 2 is 45.
Oh, okay.
Make sense? Fun party trick. You can actually do the division. If you do digit by digit, left to right, you can write it out as people say the digit, because everyone on the right, left to right. Right? Yeah. So see if you can start working through this question. But for example, if you you can just tell a friend, oh, give me any, like any number, I can divide it by 2 straight away in like seconds. It looks like you are just writing, it looks like you already got it done and then you are writing the answer, but no, you're actually solving it as you're writing it. And this is really cool because in methods you have to do, and in specialists as well, you have to do a lot of factor tree.
Yeah.
Right? And so you have to divide by 2 or 3 or like small numbers quite a lot when you are factorizing those. So let's see, 3, 7, 8, 4, 6, 2, 1, 5. Let's say 8 for example. Divide that by 2. Go.
So I take the first one, divide by 2. 1 remainder 1.
But you think of the 1 remainder 1 in your head. Just say 1. Right, I'll just write the digits
Oh.
down.
And then 7. So that's remainder.
Remember what? There was a remainder before, so that'll be 17.
Oh, 17. Okay, that means that's 8 remainder 1.
Mm-hmm.
And then 8. Does that just become 4?
No.
Oh no, 4, 18.
18,
oh,
yes.
So 9,
Mm-hmm.
2, 3, 1. What happened? Oh, do I do 1, 5 next? So 15?
No, so you go digit, so 1 divided by 2 is 0. 0 times.
Okay.
And then?
And 5, so that's 2, and then...
Not quite. 0 times 2, and which is 0, remainder 1. If the previous digit is an odd digit, then it will be always 15. Right? The next digit will have 1 added to it as 15. Yeah?
Okay.
Okay, so then?
So then 7, and then 9.
Yeah, that's right.
Oh.
So you can read out the digit, left to right.
Okay.
You don't actually need to so see, okay, we'll try one more example. 6, 4, 7, 2, 8, 1, 3, 4, 9. All right, divided by 2.
3, 2, 6, no. 3, and then 6, 4, 0, 6, 7, and then 4, 1, 0. What is it now?
0.5.
Oh,
Because when you divide a
Oh.
odd number, it always ends in 0.5.
Okay.
So the last remainder is remainder 1, right?
Yeah.
When you divide it by 2, it's 0.5.
Oh,
Yeah, so that's why I'm telling you that you can divide any whole number
Yeah.
by 2 straight away in one go. It looks like you can do it in one go, but you're actually just doing it digit by digit.
Yeah. Okay.
Yeah. Okay. Cool technique.
Yeah.
So that's how you can divide a big number by a single digit number really easily.
Okay.
If you're comfortable, you can do 2 digit, but there's a different technique for that. Okay, so that is write recurring decimal as a rational number. Okay, let's see. What else? I'm just gonna go straight to the worked examples. Smaller subset. Okay, I'll get you to the Surds part of it. Oh, did you learn to prove that a number is irrational? Can you prove that it's irrational?
I don't think we did.
No? Okay, try this one. So in specialist, you learn something called proof.
Yeah.
Okay, and this is called proof by contradiction. The technique
Oh, we
is.
got taught that for circle theorem.
Oh, okay,
Yeah,
okay, good. Yeah. So proof by contradiction. Okay, so you assume something and show that it's nonsense.
Yeah.
Yeah. So assume. So step 1 is assume. Assume square root 2 is rational. Right. Which means that now once you assume that it's rational, you have to understand what's the definition of rational. It can be written as a fraction. That's right.
So square root of 2 over 1.
No. So you let square root 2 equals to a over b.
Oh, okay.
Right. If it's a rational number, it can be written as a fraction, right? Yeah. And then when you square that, you get 2 equals to a squared over b squared.
Oh, yeah.
Yeah. Okay. And then I think you would write 2b squared. Right. 2b squared is equals to a squared.
Yeah.
Okay. And because this is a perfect square, when you multiply that by 2, 2 is not a perfect square, so you cannot form a perfect square. And because of that, this one is not, is not possible.
Oh.
Okay, so that's one way. Let me see how your textbook is saying it. Even number, most of even. Oh yeah. I think you consider. Yeah. Okay. See if your teacher will mention back to this one later on. Okay. But for now, I'll leave it be at this point here.
Yeah. Okay.
Okay. So prove that is irrational. Okay, what's the next one? The next one is, do you know how to simplify surds?
Yes.
Okay. Are you confident?
I think so.
Okay, all right. Simplifying surds. Let's try one of these ones here.
Oh, 384.
Okay, what? Tell me what's the technique to simplify surds? You don't need to do it in your
find the
head.
square numbers.
No.
Oh.
That's not the technique I recommend.
Oh.
Have you? Were you taught using the factor tree to simplify surds? It's called prime factorization. No?
No.
Okay. All right. There you go. So, like when you hear your teacher saying, "Oh, think of a perfect square," and then that you can be a factor and stuff like that, right? That technique is like, if you're smart, you can do it, or if you are familiar enough, you can do it.
Yeah.
What I like to teach students are techniques that will work regardless of whether you know the number or not, and it's like a fail-proof technique.
Yeah.
Sometimes it would. Some people say, "Oh yeah, it may take a bit longer if you have a better intuition, then it might take a bit shorter." But these techniques, like when in doubt, when in exam, when you're blanking out, you remember the techniques, and it's muscle memory. You just do it. Okay. And the technique is called prime factorization. All right. Yeah. So I'll just show you the basic technique first. So for example, a number like 100. Okay. Yeah. The easiest way to do this one is you always divide by the lowest number possible. Right? Don't try to think of dividing a bigger number, because if you go 10 and 10, it will get a little bit messy. So I'll show you 2 and then 50. Just check, 2, 3, 4, 5, right? It can be divided by 2, then just divide by 2, and 25. So this is divided by 5. Yeah. Okay. The reason why I do it this way is because this is called a factor tree. You can look at the leaf of the tree. It's like an upside down tree, right? Yeah. So you look at the leaf of the tree. This one is the same as 2 squared times 5 squared. Does that make sense?
Yeah.
Yeah. So when you need to do something like square root of a number like that, you can just go square root 2 squared, which is 2, and then times square root 5, which is 5. So 2 times 5 is 10. Okay. So of course, you know what square root of 100 is. That's easy. But if you get a number like 384, now I'll show you the same technique using this number here, 384, right? Again, this is why I taught you the technique to divide by 2.
Oh, yeah.
Does that make sense? So you always divide by the smallest number first, because the moment you divide the big number by 2, it makes it a lot smaller and it's easier to deal with. So you see 384 looks scary, but divide by 2, 192. Yeah. Can you divide by 2 again? Yes, of course. Divide by 2 again, that'll be 96. Yeah. Can you divide by 2 again? Yes, of course. By 2, so that'll be 4, 8. And you can keep going, right? 2, 24, 2, 12, and then 2, 6,
2, 3.
And then 2, 3, that's right. Okay?
So 1, 2, 3, 7. 2 to the power 7 times 3.
Times 3, that's right.
Yeah.
So therefore, right, based on this, we got square root of 384 is the same as square root of 2 power 7 times by square root of 3, right? Or let's just write it as this one here, 2 power 7 times 3. And then what you want to do is to break out an even number, so you get square root of 2 power 6 times square root of 2 by 3, like so. Yeah, square root 2 power 6 is?
2, 3.
Yeah, 2 power 3, yeah, you have the number. Did you learn this? Square root means to the power of 1/2.
Oh, yeah.
Yeah? Okay, so you times the power 1/2 into 6, because power in a power, you multiply them, right? So that would be 2 power 3. 2 power 3 times square root 6, which is 8 square root 6.
Oh.
Okay? Like, would you be able to see that this number is divisible by 64? I couldn't see that. Yeah. There's no way you can see that, but if you just apply the prime factorization, bang, your number's a lot easier.
I think we actually did this, but I just forgot.
Oh, okay, that's fine. Because it makes sense. Like, this is a more surefire method of doing this factorization, right? So same thing with this one here, 3 square root 405. So 3 square root 405. Same thing, you can work out the prime factorization on the side here, right? So that would be 5 and
91. Oh no, 81.
81. Now, this is already a perfect square. Sometimes you can cheat a little bit, right? Yeah. If this is 81 and it is a perfect square, which is 9 squared, right? Yeah. Then you can instantly write this one as 3 times
root 5 and then
times by 9 squared, yes.
Yeah.
Okay, which means it's going to be 3 times 9 times square root 5, which is 27 square root 5. Okay, so sometimes in the prime factorization, if you see like if you see a perfect square, you can just stop there.
Oh,
If you're trying to find surds, right? Okay, have you learned cube roots and stuff?
Oh no, I haven't done cube roots.
No, okay, so just surds. Okay, that's fine. So that one's the same thing. This one, x and y positive real numbers. Okay, so these are all positive numbers. Let's try question D. All right, 5 square root 180 x cubed y 5. So 5 square root 180 x cubed y power 5. Okay, so this one technique's the same for 180. So now that you're a bit more comfortable with the prime factorization and you're aware of this again, there is a little trick where if you can see a perfect square as part of the factors, you can actually do that first. No, so the combined will be 20. Right? And then once again, I'll split into 4 and 5. Okay, so then that will be 5 times by square root of 9 by 4 by 5 by x squared by...
Why don't you put 4 into 2 and 2?
Because 4 is a perfect square. You can square root 4, which is 2.
Yeah. Okay.
Right? So this is like a little bit more advanced, slightly more advanced, not hard, but you just gotta know what you're doing. Like that.
Yeah.
Okay? So then you distribute the square root into the stuff that you can actually simplify, which are these ones here. So that'll be 5 times 3 times 2 times x times y squared. And then in the square root is only 5xy.
Oh, okay. Yeah.
Okay? Yeah. So then that will be 1030 xy squared square root of 5xy.
Okay, yeah.
If you want to simplify that way. It looks a bit strange though, because normally you don't get to this part. But yeah, that's fine. Alright, make sense?
Yeah.
So that's simplifying surds using prime factorization. So skip these ones. What else? Simply addition and subtraction of surds. How comfortable are you with these ones?
We can try.
You can try? Okay. Alright. The easiest way to do this one is to notice what's in the surds, right? And you have to simplify everything first before you can actually see. So the idea is that if you have 3 and then square root of doesn't matter, 7 minus 2 of say square root 7 is just 1 square root 7, right?
Yeah.
So this is the same as like 3a minus 2a equals 1a.
Yeah.
Right? Same thing. Yeah. But then you need to make sure the surd is simplified. Because sometimes you would get something like square root of 28. Whoops. You might get something like square root 28. Right? And then you have to simplify that. If you simplify 28, it's 4 by 7, which means it was square root 4 times 7, so that's 2 square root 7. So technically you can simplify. Alright, but you need to be able to simplify all of that first. So the first one is simple, right? They're all square root 6. So you just do 3 plus 17 minus 2.
Yeah.
Easy. Now the second one is a little bit different because that's square root 12, square root 2, square root 8, and then square root 3, right? So let's try question B. 5 root 3 plus 2 root 12. So I like to write them a little bit further apart so I can see how many terms there are. How many terms are there in this expression? 4. Good. Okay. List them up for me.
Would it be 5 2 negative 5 3? Oh no. Root 3, root 12, root 2, root 8.
I see. Terms are separated by plus and minuses. So I would read the first term as 5 root 3. The second term as 2 root 12.
Yeah.
The third term is negative 5 square root 2. The term comes with a sign in front of it.
Okay.
The third one is positive or just 3 square root 8.
Yeah.
The reason why I like to think of like how many terms, how many factors is because you can swap the terms around. You can swap these two terms as long as you bring the sign with them, it will be correct.
Yeah.
So for example, in this case, no, actually I'll keep them the same because I think they're already in the nice order for you. So yeah, so now you simplify. You can actually simplify the like 12, 4 by 3 on the side here, and you know that's going to be root 4. Right, root 12 is root 4 times 2 square root 3, right?
4 root 3?
Yep. And then?
And then 4 to 2 root, 6 root 2.
Yeah, 6 root 2, that's right. So just combine. That will be 9 square root 3 minus 5 plus 6 is plus square root 2.
Yeah.
Okay? Alright? Same thing with this one here. I'm not going to go through it. I think you can do it.
Okay.
So yeah, just make sure you simplify that first before you combine them. Let's see. Determine the perimeter. So we're getting to the problem solving questions now. Okay. All right. How do we find perimeter?
Length. All the lengths add together.
Yep. So what would that be for this question?
2 and then brackets the length plus 2 and then the width.
Yep. Not wrong, but you can combine them together.
Oh, okay.
Right? It's like 2 length plus 2 width is like 2 times length plus width.
Yeah, okay.
Alright, so you can add half of the perimeter and times it by 2.
Yeah.
So yeah, then just simplify and combine. Okay? Simplify. What would 2 square root 50 is? Can you do it in your head?
5 root 2.
Mm-hmm. That's not the answer. This is
10 root 2.
yeah, 10 root 2, that's right. Okay?
32 is 4 root 2.
4 root 2? Yes, plus 4 square root 2. Yeah. And then you gotta simplify that, right? So 17, so 2 times 17 plus 5 is 22. Minus 10 plus 4 is negative 6 square root 2. And I'm not sure if your teacher will want the expanded version. I'm assuming it is. So it's going to be 44 minus 12 square root 2 meter. Okay? Yeah. So for working with Surds is not hard. You just need to know how to simplify. And the technique to simplify is a factor tree. That's it.
Yeah.
Alright. So that's addition and subtraction. Multiplication. Just remember when you multiply 2 surds, it will cancel out. We've been doing the reverse of it. We've been doing getting this form and then we split that up in order to simplify.
Yeah.
Okay, so when you multiply, it's just combining them. I think it's not too hard. Should be okay. Yeah, I'll leave these questions in here for you to try. Alright, so multiplying surds. Try some. Okay. You don't need to do all of them. Just look at the ones that you think will be difficult for you to do, and then try those ones. Okay. So this is multiplying surds. Yeah, I'm not gonna go through that. I think it should be easy for you. Okay. What else? This is roughly halfway. Division of surds. Same thing.
Yeah.
Okay. Should be easy. Alright, check this one in here. So the idea is that after you get these notes, if you want to revise, just open this and work through it. Okay, so try some. And this topic is division of surds. So nothing much to teach. It's just make sure you do enough practice on these ones. And then distributive law.
I don't think we covered this one.
It's pretty easy though. It's just the distributive property.
Yeah.
You just times it like from here and you times it into each term in the brackets.
Okay.
Right. It's not hard. Okay, that's fine. If you didn't cover this one, then that's fine. Just double check, okay, that you didn't cover this one. But alright, that's the end of surds.
Yeah. Oh, we also do like I think if you have like a surd as a denominator and a integer as a numerator, there was like realizing the denominator.
Rationalizing the denominator.
Oh, rationalizing.
Yeah. I think it should be that's the next chapter.
Yeah.
So rationalizing the denominator is basically times the bottom by a surd, by the same surd in order to simplify it.
We do that in the complex numbers as well.
Yes, you do that, yeah. Okay, so rationalizing the denominator, in this case, say for question A, right, it's just times. The idea is that you want the bottom to be a rational number, right, not an irrational number, and so you times it by the same thing as the bottom. In complex numbers, you times it by the conjugate.
Yeah.
Right, because when you multiply, you get like a nice form. But yeah, so this one would be square root of 6 and 13. You can't really combine them. What's 6 times 13?
6 by 13. I don't know my 13 times tables. I don't know my 13s.
Okay. You don't need to know your 13s. I'll show you the technique. That would be 78 over 13, and you can't simplify that. So how do we do something like, okay, this is a side note. Okay. How do we do something like 6 times by 30? Now the trick is actually really handy.
60 and then 6 by 3.
Yeah, that's right. Yes. You do 6 by 10 and 6 by 3. So 60 plus 13. Right? And that actually works for bigger numbers as well. So let's try 7 by 24.
168.
Yeah, good. See? Easy, right?
Yeah.
So yeah, I think it should be fine. So that's just so it'll be 7 by 20 and then 7 by 4, which is 140 plus 28. So that would be 168.
Yeah.
Okay. All right. So you don't need to know all your times tables, just need the basic ones up to 10.
Yeah.
Okay. All right. So that's rationalizing. Okay. Maybe we'll go through question C. Question C looks a little bit trippy, but it's not too hard. 14 over square root 7. So the idea is that when you times the top and the bottom both by square root 7, right, it's very important you put the brackets around here.
Oh, yeah.
Why? How many terms are there in the top? Let's say before we times it by square root 7. How many terms are there in the top? 2. What are they?
Root 17 and negative 3 root 14.
Yes, correct. If there is more than one term, aka 2 or more, when you multiply, you need to use distributive property.
When there's more than 2 terms on the denominator, do you have to multiply by the conjugate?
In the complex numbers, yes, but in rational number, there's no conjugate of surds.
So if those two were flipped, right? I would multiply by root 17 minus 3 root 14.
If they are flipped, you would multiply by the plus version. It's not called a conjugate, but you do more. Yeah. Okay, actually, I'll show you that version here as an exercise. I don't think you'll see it, but just in case you do.
We covered it in the exam.
Really?
My friends told me that they did.
Oh, okay.
Yeah.
Okay. Might be later. Let me see if it might appear later as one of the questions. Rationalizing. Oh, right. Conjugate surds. Oh, yes. Conjugate. Yeah. Strange that you're supposed to learn this one here. Fine. We'll go through that later. Yeah. Okay. We'll go through that a little bit later. So this one is easy, right? It just times it in, and 17 is a. Can you simplify? No. So 17 is a prime number, so you just gotta times it in. What's 17 times 7?
17 by 7. 139.
No.
Yeah. 70, 49, 119.
Yeah, 119.
Yeah.
So square root 119 minus, and you split the root 14 into root 7, root 2, right? So that would be 3 times 7, which is 21 square root 2, okay, over 7. And square root 119, you can't do anything about it. So I think that's the best you can do. All right. Next worked example is the one on the conjugate surds. Didn't remember that they use the term conjugate surds. And it's not part of the actual specialist content.
When are we supposed to learn this?
This is Math C.
So they don't cover this in specialist? Oh.
No. I'm pretty sure they don't. Or maybe they do, but in like a very small section. They cover the rationalizing denominator, I think, but not sure about this one. It's alright, it's the same technique. They might throw this onto you as a complex familiar question. You gotta sort of figure it out yourself. So rationalize the denominator and simplify the following. The idea behind this is based on something called difference of perfect square. Have you learned this?
Oh yeah, I've heard of that.
Okay, of perfect squares. Alright. What is the difference of perfect squares? What's the formula?
Isn't it like brackets a plus b and then brackets a minus b?
Yeah, correct. Yeah. And then that will be equals to?
A squared plus b squared.
A squared?
Plus, minus b squared.
Minus, because it's the difference.
Okay.
Alright, so it's a squared minus b squared, because it's called difference of perfect squares.
Yeah.
So this is the difference of two perfect squares.
Yeah.
Right, and then you factorize that into this form here. Yeah? Right? If you know this one, you'll be fine for math methods.
Okay.
For the quadratics, the first part of it. Anyway, so for question A, 1 over 4 minus square root 3, when you times it by the conjugate of that expression there, okay, then the bottom just becomes
16 minus 3.
yeah 16 minus 3, yeah, which is 4 plus square root 3 over 13.
Oh, yeah.
Pretty easy,
Yeah.
right? Now for question B, you need to use the distributive property.
Oh.
Alright, so I'll show you the workings, but you definitely have to go back and try this again at home yourself to make sure you get the algebra right. So 3 plus square root 3, and then you want to times both top and bottom. But remember, when you times an expression with two terms, brackets.
Yeah.
Okay, and then times by the conjugate 3 minus square root 3, 3 minus square root 3. Then that would give me the bottom to be easy, 9 minus 3, which is 6.
Yeah.
Right? Then the top, you need to do the distributive property for each of the terms here.
So 3 root 6, and then minus root 18, and then plus 9 root 2 minus 3 root 6.
Yeah, that's right. Okay, and so 3 root 6 minus 3 root 6, these two will be gone. What's square root 18?
Square root of 18, 9.
9?
Yeah. Wait, would it be negative?
Negative, yes.
Oh. Yeah. Oh no, 9 is 81. 2, 6, and 3. Root 3, root 6.
No, you find the perfect square in 18. If you can't factor
9 and 2, so it's
yeah.
3. Yeah, 3 root 2.
3 root 2 plus 9 root 2. That's alright. Just forcing you to do it mentally. You don't normally need to do it mentally, right? If you want to, you can just go, oh, 3 9, oh, perfect square. Now, if you do enough of this factor tree, you can see it in your head. But like, it takes practice, is what I'm saying. It's okay if you can't do it straight away, that's fine. So that'll be 6 square root 2 over 6 is beautifully just square root 2. Alright, that massive expression is just equals to square root 2.
Oh.
Cool. Yeah? So I think that's it. What else can you remember from the Surds chapter?
I think that's all.
That's all?
Yeah.
Okay. So yeah, this one just combine and then simplify, combine.
What would like
simplify.
a worded problem for a set be?
Let me see.
Because I don't remember we did anything of it.
Have you learned modulus?
No.
Okay, I think that was the end. I don't think you'll get a worded problem. You don't get a problem solving one.
When would you use sets in real life then?
Surds?
Yeah.
You actually do that a lot in methods because when you're solving quadratics, right? The formula has square root in it.
Yeah.
Like b squared minus square root for b squared minus 4ac. Sorry, minus b plus minus square root of b squared minus 4ac. So the surd is in the quadratics formula, and the quadratics formula is used very often. Yeah, similar to some other formulas as well. So maybe I'll just show you one last one. Now, tell me what would you multiply the top and bottom by? If you get the right answer, then maybe we can skip this.
2 plus root 2 minus root 3.
Sorry? So
brackets 2 plus root 2 plus root 3.
So okay, so this is the initial one, and what do I multiply?
Brackets 2 plus root 2, and then plus root 3.
Okay, plus square root 3. Good, that's right. So you multiply with this version, and then what do you get?
4.
You don't need to do too many steps at once. The first step, you can just write 2 plus square root 2, everything squared, and then minus 3, right?
Oh, yeah.
Right, and then you can simplify this squared there. What would that be?
Could I just do 4 plus 2?
No.
No.
This is a different formula.
Oh, that's the a squared plus 2ab plus b squared thing.
Yes, that's the one.
So 2 squared, so 4 plus 4 root 2 plus 2.
Yeah.
Ah,
Yeah.
got that.
And then minus 3. Alright? Okay, not bad, not bad. You actually know that formula. So that, I think you should be okay with that. Now plus that, and then the bottom would be simplifying that. 6 minus 3 is 3, so that'll be 3 plus 4 square root 2. Simplify one more time. You gotta times the top and bottom by
The conjugate.
Mm-hmm.
So 3 minus 4 root 2.
Yep. Now can you get the bottom straight away?
9 minus 32.
Yep. Okay, so the bottom will be 9 minus 32, and then the top will be
3 times
3 times, yes. You just gotta go through it. Go on, try.
6 minus 8 root 2 plus 3 root 2 minus 4 times 2 minus 8, and then plus 3 root 3 and then minus 4 root 6.
Okay, good.
Yeah.
All right, very accurate, very good. So yeah, just want to simplify this one. 6 minus 8 is negative 2, and then minus 5 root 2 plus 3 root 3 minus 4 square root 6 over 9 minus 32. So minus 2 first, that is 23. Okay. You can, at this point, because the bottom is a negative number, you can times top one by negative 1. What would that be then?
2 plus 5 root 2 minus 3 root 3 plus 4 root 6.
Very good. Just flipping the terms of everything. All right. Very good. We can skip through a lot of the basic algebra. One question and I get a rough idea of how you go in your basic algebra. You're fine. All right. Maybe you can go faster. So yeah, that's the end for Surds. The next one, Combinatorics. I think it's chapter 10. Yeah. Permutations and combinations. You remember this much about this one?
No. This is my weakest one, I think.
The weakest one?
Yeah, especially in weather problems. Yeah.
Yeah. Not easy. Let's see if I can give you a So the main thing about permutations and combination is that in permutations, the orders are important. So the order is important means it's permutation.
Oh,
Okay. Combination is when the order is not important. All right.
Yeah. So in combinatorics, do you use like factorial? In combinatorics.
Yes, you have to use factorial. Yeah. So let's see. Maybe I'll skip through these easy ones actually. I'll just use the textbook explanation for these ones. All right. So list all the different ways that this may be done. If the order is important, you're supposed to choose 2 letters. So the idea is that you would pick the first letter and then see each of the, you can combine the first letter with each of the other ones.
Yeah.
Right? Okay? And then that's how you get the first row here. Right? And the order is important. So AB is different from BA. Yeah. A first, then B is not the same as B, then A.
Yeah.
Okay? That's when the order is important.
Yeah.
And remember, combination is when the order is not important. Right? So this is permutation. And list all the different ways this will be done. The number of ways, it will be 25 ways basically. Okay? Because if you pick the next number B, there will be 4 other options for it to combine with, right?
So for this kind of question, do I just to see how many letters there are and then times by itself?
Yes.
Oh, okay.
Yeah. So we get to the permutation formula in a little bit, very soon.
Isn't there like a P and then a number at the top and one at the bottom? I don't know which one.
NPR.
NPR, yeah, that one.
Yeah, that's an NPR one. Okay, maybe I'll get to the NPR stuff. How many ways? Addition, multiplication, principle. I think these are the hard ones. Okay. Alright, factorials. Have you learned about factorials?
Yeah.
Okay. You're okay with these concepts? Alright. Just one quick question.
Oh, the last one, yeah. I remember that kind of question. I struggle with it.
Yeah, thought so. So, when you're doing factorials, you just got to remember one important concept. So this is chapter 10. Combinatorics. A number factorial, for example, let's say n factorial, right? Normally they would write this way. It's 1 times, I prefer to write this way. 1 times 2 times 3 times all the way to n. Right? Then I'll n, whatever it is. If it's 100, it'll be 1 times 2 times 3 times 4 times 5 all the way to times 100. Right?
Okay.
But you can write it in some other forms, and these other forms are what trip most students up the most.
Is it n minus 1, n minus 2, n minus 3?
Yes, but n minus 1 is like the number right before that. Right? So I would write it as times by n minus 1 and then times by n. It's still the same.
Oh.
It's still equivalent, right? Because n is 7, n minus 1 is just 6. Right? It's the same. And you can keep on expanding it forever, right? Assuming n is like a big number, you can just keep on expanding it. So you can get n minus 2 first, and then times by n minus 1, and then you times finally by n. These three expressions are all equivalent to n factorial.
Yeah.
They're all equivalent.
Yeah.
Okay? And so let's try question C. The first few ones are easy. 18 factorials over 5 factorial. Right? Now, you need to see that 5 factorial. So start with the smaller one first. It will be 1 times 2 times all the way to 5.
Oh, yeah. Normally we like flip it. So 5 times 4 times 6 times
I know.
2 times 1.
Yeah.
Yeah.
I know. That's okay. Maybe I'll write it in the flip version. I prefer to write in the forward version.
Oh, okay.
But because I think to me it makes a bit more sense because they all start at the same point. See if the forward version makes a little bit more sense.
Yeah.
So times all the way to 5, right?
Yeah.
And then the top, you start from 1 and then times, and then you will show that it's times by 5 and then times by 6 and then continuing to all the way to 18.
Oh, okay.
Does that make sense?
Yeah.
Yeah? So you're writing it this way, you can see that the top and the bottom here can be cancelled off.
Oh, yeah.
So this is the same as 6 times 7 times all the way to 18. Alright?
Yeah.
So I think this, to me, this is a little bit easier to see.
Yeah, this makes more sense.
Right? It makes more sense, right? As you're counting up. Because counting down is a bit harder to know when to stop, I think. Yeah. So so that's why it's just 6 times 7 times all the way to 18. Just punch it in and get the answer.
Yeah.
Okay? So same with this one here. N minus 1 factorial. Let's try this. Question E, is it? Yeah. So n minus 1 factorial over n minus 3 factorial. Okay? So again, I'll write the top, I'll write the smaller version first, which is the bottom, right? N minus 3. Sometimes you need to test out this one. So test n equals to 10. Then n minus 1 is 9, which is bigger. And then n minus 3 is 3 minus 10 minus 3, which is 7, right? So you start with a smaller factorial. Right? So sometimes to see what's smaller, what's bigger, just choose a number for n, right? To test it, just to help your mind to see, n minus 3 is the smaller one. So smaller one means you would go 1 times 2 times all the way to n minus 3.
Yeah.
Right? See if you can list out the top, 1 times 2 times all the way to n minus 3. Right? But then you need to keep multiplying n minus 2, n minus 1, and then, that's it.
And then that just equals n minus 3 and n minus 1.
Yeah, that's right.
Oh.
Make sense?
Yeah.
Yeah? Much easier to see, right?
Yeah.
Because people read left to right. I think the formula, I know that the textbook write it the other way as well, but it's so hard to simplify. Like looking at this one, I see the first few numbers like, oh my god, that's not the same as this. You have to recognize that the tail of it is the same, which sometimes is a bit hard to see. So I like to start from the other direction. Yeah. It's strange how they do it, but that's fine. I think it's mathematically defined that way. In some cases, it might be a bit easier. Right. Oh yeah. So NPR, the formula is, so this is a permutation. Permutations. So NPR is n factorial over n minus r everything factorial. I think, pretty sure. Yeah, n minus r factorial. Okay. So NPR is the idea of like out of n objects, if you are to choose. So for example, right? I shouldn't really use a textbook one. This one. I think the tricky part for combinatorics is you need to recognize when to use NPR and when to use NCR.
NCR.
Have you learned that? Combination?
We didn't learn NCR.
It's part of combinatorics though. It's combinations. There's always permutation and combination.
Maybe I forgot that.
I think so, yeah. Most likely you have learned it. So Netball Club needs to appoint the president, secretary, and treasurer. From the committee, 7 people have volunteered for this position. Each of the 7 nominees is happy to fill any one of the 3. In how many different ways can these positions be filled? So you see how this one is important because you can't just pick 3, right? You have to allocate, let's say, A, B, C, D, E, F, G, right? So 7 people is like A, B, C, D, E, F, G, right? So let's say this is the initial of their first name, right? So if A is president, and B is secretary and C is treasurer, this is different from A, C, B.
Yeah.
Alright, so the order is important. Okay, because order is important. So note that order is important. Therefore, this will be a permutation question. Okay, it will be a permutation question. Alright, and they're saying that 7 nominees and you want to select 3 positions. That will be N, P, R of 7, actually I'll write it as 7. So N equals, so N, use NPR where N is 7 and then R, how many you're choosing is 3. Yeah? So 7 people and then you permutate to choose 3 out of the 7. Okay? So then this would be 7 factorial over 7 minus 3 factorial.
Yeah.
Okay? So 7 factorial over 4 factorial.
Yeah.
Alright, so 7 factorial is the same as 4 factorial times 5 times 6 times 7. Alright, did you learn to write it this way?
Yeah.
Maybe. Yeah, because normally you have to write it as 1 times 2 times all the way, what I said earlier, which is...
Yeah, I can see that. Yeah.
Right, and then you gotta roll 5, 6, 7.
Yeah.
So a little trick, and it's mathematically correct, your teacher cannot mark you wrong, is to write 7 factorial as 4 factorial, and then you times the numbers after that. Right, and then the bottom is just 4 factorial. Bang, cancel.
Yeah.
Okay, so it'll be 30 by 7, 210 ways.
Okay.
Yeah? Okay? So the trick again is to realize that order is important because I'm assuming that you will need to learn combinations. That's when it's a bit tricky knowing like when to use what.
Yeah.
Let's see, arrangement in a circle.
Oh, arrangement in a circle. I remember covering this.
You had to do this one?
Yeah.
Okay. So I think just have to learn the formula. A number of different ways. I don't remember this one being taught in specialist. But it's okay. If you might get tested, might as well learn it. Yeah. So the number of different ways n people can be seated r at a time in a circle is you got to divide by r.
It's very specific. Is this formula only used for this?
Only used for circular arrangement, yes.
Oh, okay.
Yeah. So this arrangement in the circle. I think it's something that easier just to remember, and when it comes up, just use it. Okay, so note that this is arrangement in a circle.
Yeah.
Okay. I think it is because when you have, for example, when you have A, B, C, D, right? If you rotate that and start B first and then C, D, A, it's the same. Does that make sense?
Yeah.
Yeah. Or if you start with C first and then D, and then A and then B in a circular form, right? It's still the same order.
Yeah.
Yeah. So that's why you have to divide by R, which is the size of the circle.
Oh.
Right?
Okay.
Make sense? So like it will be D and then A and then B and then C. Because when you read clockwise, it's A B C D and then A B C D, A B C D.
So if you
A,
have
B, C.
like 5, like A B C D E, you divide by 5.
Yeah.
Oh.
Yeah. So if you're selecting 5 people in a circle of 5, then you divide by 5.
Okay.
Yeah. So that's what explains the divide by the number R. Pretty simple, right? Easier to just remember the formula than trying to deduce it in the exam. Okay, but yeah, of course, to remember it, you need to understand like why you divide by the size of the circle. Is because you can rotate them around and it's still the same thing. How many different arrangements from a group of 8 people, 5 are to be seated at a round table? So the answer would be n. So that would be 8 p5, and then you have to divide by 5.
Oh.
I'm not going to look at how the textbook does it, but I'll show you how I would do this question. That's 1 over 5, right?
Yeah.
And then times by the 8p5. So that'll be 8 factorial over 3 factorial.
Yeah. Okay.
Yeah, because I'll write it as 8 minus 5.
Yeah.
Okay?
Yeah.
So that will be 1 over 5 and then times by, now 3 factorial. So 8 factorial is the same as 3 factorial and then times 4 times all the way to times 8. Oh, actually, we can list it out. It's not too many. Right, and then over 3 factorial.
Yeah.
So once again, 3 factorial cancelled out. So it's not just the 3 factorial, but also the 5 here will cancel out. Okay? So then that would be 4 by 6 by 7 by 8. Now this one's a little bit harder to calculate. You can try to combine them. So 4, 6, 24, and then 7, 8, 56. Can you times 2 digits? By 2 digits?
By hand I can, but not
yeah, by hand is easier, right? But if you want, you can just do the same thing where you times 5 by 24 if you're comfortable. That will be 120, but then add the 0, so 1200 plus 120 plus 24, 144. So that'll be 1344.
Oh.
Yeah, so I'm just doing 24 times 5, 50, sorry, 24 times 50, which is 24 times 5, add a 0, and then 24 times 6.
Okay.
Yeah, so that's one way. But of course, you can also do the 24 by 56, that's an okay method as well. Yeah, I just like to write it this way so I can see the split and practice your multiplication. So yeah, that's a one. And note that the trick is to write it this way so you can do the simplification here. Right? And it doesn't look like fraction in a fraction, it looks too scary sometimes. So yeah, go back, try these ones out. Arrangement involving restrictions and like objects. Restrictions, okay, and things are good. Have you learned this one yet?
Oh yeah, we had this one.
Yeah, okay. So n things in the first group, n2 in the second group, and so on is that one. Oh, these counting ones. I don't remember seeing this one in specialist, but might as well go through that. So this is for when you have restrictions. Number of different ways of arranging n things made up of groups of indistinguishable things. Yeah, this formula is a strange one. I personally have not seen this formula yet. Let's see. Okay, how many different arrangements of 8 letters can be made from the word parallel? So different arrangements of 8 letters. In the first group, and 2 in the second group. You've done this one in, do you remember, this one was in...
I remember this in class.
Like, in class?
Yes.
Okay. I might have to get back to you on this one later because I don't have a best way to explain this concept to you yet.
Okay.
Repeat it twice, yeah. Okay. I think the best way is just to read through this example here. Because I'll be honest, I don't have a better explanation than this one.
Okay.
Don't remember this one being specialist. That's fine. Give it a go. If it doesn't make sense, let me know.
Okay.
Alright? And I'll provide you a separate one. Alright. 7 counters made from 4 black and 3 white counters. So yeah, using this, it's just the same formula where the first group has 3 and the second group has 4. So 4 black counters and then 3 white counters. And you want arrangements of how many arrangement of 7 counters?
Why did they put 3 factorial first and then 4 factorial second?
It doesn't matter.
Doesn't matter. Okay.
Yeah, it doesn't matter. Oh, whoops. Yeah, it doesn't matter because if you flip the n factorial to n1 factorial, it's the same. It's like how writing 1 times 2 times all the way to n is the same as n times all the way to. Yeah. Okay. All right. Let's see. So that's the example. That's that one there. Yeah. These restrictions on. Might have to get back to these ones for you later.
Okay.
Restrictions and like objects. Yes. The next topic was combinations. Okay. Now, combination is where order is not important, as I mentioned earlier.
Yeah.
Okay. It's called a combination. Like the idea is that, let's say, yeah, I'll use this example here. 5 people have been nominated for a committee consisting of 3 members, and it doesn't matter in which order, ABC or ACB is the same.
Right.
Right? Because A, B, C, and then ACB is the same in this case.
Yeah.
It's still the A, Angela, Candy, and boy, whatever, right?
Yeah.
So it's the same 3 people. So order is not important, and I think the formula they will tell you, yeah, here. So this is the formula here. NPR over P factorial. Do they not give you the simpler version? Okay, fine. I'll give you the simpler version. Okay. Yeah, you need to practice on these questions.
Yeah.
Combinatorics is like one of the trickiest one. I think especially in the exam, it's hard because you don't know what to use. Right? So this is about combinations. Combinations is used quite a lot in both specialist and methods.
Yeah.
Permutations, not so much. You learn a bit of that in specialist, but combination is used a lot more because of the binomial expansion. Have you learned binomial expansion?
No, I don't think so.
Okay, that's fine. You get to that a bit later. Okay, number of ways of choosing or selecting R things from N distinct things where order is not important. So this is the formula, but I will give you a different, slightly different formula. So it'll be N factorial over N minus R factorial and then times by R factorial. So you see what they're saying, the NPR is basically just the first part here.
Oh.
Right? When you divide by R factorial, it's times by 1 over R factorial.
If I write this formula in the exam, is that okay?
Yeah, of course. Yeah, it's the same. These 2 formulas are the same.
Okay.
Yeah, I just don't, because if you write it this way and then when you solve NPR, then you get like something like this.
Oh, yeah.
Do you know what I mean?
Yeah.
That one doesn't look as nice as when you have it in this form here.
Yeah.
Yeah. So that's why I prefer this version here. But basically the NPR is just the highlighted stuff there. Okay. So practice using the other formula. I think it will be a bit easier. Calculate these ones. Now just go straight to a question here. Okay. All right. In how many ways can a basketball team of 5 players be selected? Whoops. From a squad of 9, if the order does not matter, so you just choose 5 players. Now, this question can be changed quite differently if they list the positions. It's like, I don't know what the positions are in the basketball team.
Me neither.
Yeah, but anyway, if they have like a forward or whatever, if you have to arrange them into positions, then that will be permutation.
Oh.
Okay, but if the order in which they are selected does not matter, and sometimes in the exam, they won't tell you this. They will just be like, oh, select a committee of 5.
So how do you know which one to use then?
If they just say the committee of 5 in any order, because sometimes it is implied that the order doesn't matter.
Oh.
Sometimes it's implied. Yeah, I'm hoping that for your exam, they will make it a bit more explicit, whether the order matters or does not matter, so you know whether to use permutation combination. I'm hoping for that, but I'm just saying, be prepared. Sometimes it is an implied.
Okay.
Yeah, they may not mention it. Okay, in how many ways can a basketball team 5? So that's a squad of 9, so that's 9 in total. So that's NCR, where N is 9 total, and then you're selecting 5 out of 9, right? So that would give me 9C5. Sometimes you will see in the calculator, they'll write it this way. So 9 and then C5.
Oh, okay.
Right? Or some calculators will be written as NCR brackets 9,5.
Oh.
Yeah, so some graphics calculator will use one of these 2 versions here. But anyway, so this one will be 9 factorial over 9 minus 5 factorial, which is the NPR part, and then you times it by 5 factorial at the bottom.
So, okay.
Okay, so then I'll just write it over here. So that would be 9 factorial over 4 factorial times by 5 factorial.
Yeah. Would that be 20 factorial on the denominator?
No,
No.
it's not the same.
Okay.
So this is 1 times 2 times 3 all the way to times 4, and this is 1 times 2 times 3 all the way to times 5.
Oh, okay.
Right? If it's 20 factorial, then it will be like 1 times 2 times 5, and then times 6 times 7 times 8, which is a lot bigger. So it's not the same. Factorial, you can't actually combine them that way. So the only thing we can do is see these 2, right? I'll write the 9 factorial as 5 factorial times 6 times 7 times 8 times 9.
Yeah.
Right, and then the bottom, the 4 factorial, I can't really do much with it. So rather as 1 by 2 by 3 by 4, and then times by 5 factorial.
Yeah.
Right, so then you can simplify these 2, and simplify some of these. So 2, 4 is 8.
Yeah.
Right, 6, 3, that would just be 2. So the answer will be 2 by 7 by 9. So that will be 18 by 7, which is 70. So that's 18. Yeah, 18 by 7, 56. Whoops. 70 and 56 is 126 ways.
Yeah.
Okay, makes sense?
Normally we do this in a calculator though.
Are you sure you don't have to do this in non-tech? Do you have a tech active or tech free?
Yeah, we have both, but like, I remember normally anything with factorials we're allowed to calculate.
In a calculator?
Yeah.
Oh, okay, then even easier. You don't need to do the simplification.
Yeah.
But at least you're aware of how to do the simplification.
Okay, yeah.
So, like for these ones, I recommend when you're practicing, right?
Yeah.
If you can do them by hand, do them by hand.
Okay.
To practice your mental math to be sharp, right? And then in the exam, if it's a calculated exam, then don't bother. Just punch the whole thing in.
Yeah.
Yeah. Okay. So that's combination. Determine the value. Yes. Another way of writing it is in this brackets form here. Yeah, I think the textbook also shows a tech-free version, no calculator version of this. But all right. So determining this value here, 12C5 is similar to what I showed you earlier. 12C5 is going to be 12 factorial over 12 minus 5, which is 7 factorial times 5 factorial.
Yeah.
Okay. Same trick. You can simplify that. So the top would be 8 by 9 by 10 by 11 by 12. And then the bottom is 2, 3, 4, 5.
Yeah.
And then you can simplify. 2, 4, 8, 3, 9, 3, 10, 2, 5, 66 by 12, which is 660 by 1 plus, right? 660, by 132, 792. See, I think if you punch it in a calculator, it will take a little bit longer. Yeah, of course, if you don't have to do this step, then it will be shorter if you punch this one in. But if you are fast enough in your hand calculation, you can get to the answer. And you can always just punch it in to double check the answer. Yeah. Okay, but always try to do it by hand if you can while you're practicing. All right, 10, 2. So this one is another way of writing it. Okay, 10 choose 2. So this one is the same as saying 10 choose a combination, choose 2, or choose a combination of 2. Alright, choose a combination of 2. So this is the same thing as 10C2.
Oh, okay.
That's it.
Yeah.
Okay, you can work through that later. Okay, so did I miss something? Did I get 792? Yeah, I did get 792, yeah. But it looks so long the way they do it. Oh, actually, no. Here. They do write the simplification. This one and this one. But I don't know, I don't like writing it in this way because you don't see the factorial part. So if you notice my working, I normally put these ones in brackets.
Yeah.
Because to me, brackets is a visual way of segregating something. Yeah. Right? And then the bottom also have brackets here. It's a lot easier to follow. Yeah. So you can see, 7 cancel off and yada yada. Yeah. Okay? Yeah. So yeah, same thing here. Yeah. Let's say this one. If I were to do this part, let's say this part, right? I would write it as 8 factorial and then times 9 times 10. Right? And then the bottom is also 8 factorial and then 1 times 2. So if you count forward, it's easier to see the simplification than counting backward. Yeah. Okay. Next, a committee consisting of 3 men and 4 men is to be chosen from 7 men and 9 women. How many ways can this be done? Okay. Whoops. Do you remember the addition and the multiplication principles?
What do you mean by that?
Okay, then the answer is no. Right. Okay, this question is an example of that. A committee of, so you need 3 men in a committee and 4 women, right? And then the group, like the population, is 7 men and 9 women. How many ways can this be done? So 3 men out of 7 is the same as 7 choose 3. Yeah. Right? And then 4 women out of 9 is the same as 9 and then you choose 4. Yeah. Right? So quickly work through that. So that'll be 7 factorial over 3, as 4 factorial times by 3 factorial. So simplify, that'll be 4 factorial, 5 times 6 times 7 over 4 factorial, 2 times 3. right? Because I'm assuming 1 times anything is just 1. 2 times 3 is 6, so that would just be 35. Yeah? So if you're comfortable enough, it's quite easy to work through these things. Yeah. And have you learned mathematical induction?
No.
No. When you learn that in specialist, you will need to be comfortable with the factorial notation and be able to simplify it into that form quickly. Because you have to n minus 1, k, n plus k minus 1 and all that stuff. So you see that later. 9 factorial over 9 minus 4, I'll do 5 factorial, 4 factorial. So that'll be simplified off the 5, that'll be 6 by 7 by 8 by 9 over 2 by 3 by 4. 2, 4, 8 cancels, 6, 3, that will be 2, 14 times 9, 90 plus 36 is 126. Okay, so 126 ways. Now the question is, a committee of 3 men and 4 women, right? So how do we, what do we do with these two numbers, 35 and 126? Do we add them or do we multiply them? Because there's the addition principle and the multiplication principle. Do we add them or do we multiply them?
Add?
Add, why?
Because it's a smaller number. And I think it will have less possibilities.
Not quite. Okay. Put it this way, 35 means that there are 35 of these options, right? Let's just say 35 options, and then option number 1 would be like male 1, male 2, male 3, right? And then number 2 could be male 1, male 2, male number 4, like for example, right? And then we keep on going, right?
Yeah.
But note that for each combinations of males, right, there are 126 combinations of females, and that will be like female 1, female 2, female 3, female 4. So that's the first combination for the females, right? And then the second combination can be F1, F2, F3, and F5, right? It's a different one.
Yeah.
You see? But note that for each combination of male, you can match it with one combination of female, and that's one final combination. And then you can match it with a different combination of female, and that's another one.
Yeah.
Yeah, right?
So
then
you multiply?
You multiply, yes. So actually these two numbers, you would need to, so total would be, right, 35 times by 126. This one most likely a calculator one. But in methods and specialists, sometimes you might get this one in a non-tech environment. Because what they're testing is like year 5 stuff. Can you multiply a 2-digit and a 3-digit? If you can't do that, then you lose the next 2 marks. Yeah.
So what would you use addition then?
Good point. Let me find a question with addition. 4, 4, 1, 10. So I'm just going to cheat that up. 4, 4, 10. Alright. Let's see. Is that the end? So combination. These application ones are tricky. Alright. So let me go back to the start. I skipped this one, but it's the addition and multiplication principle. Okay, let me give you the 2 main notes from here. So this is the addition versus the multiplication principle. Okay, that's one, and then this is the other one. You've learned all of this before, right?
Yes.
Supposedly.
Yeah.
But you missed that first term. But it will be part of the exam, you sure?
Yeah.
So unlucky.
I was just
Combinatorics is
thinking,
one of the most confusing one.
How much of this will be in the exam? Like maybe
Could be
it
one question.
One question, yeah.
But could be 7 marks out of like 60.
Yeah.
Which is still like about 10% of the exam. If you lose that mark, you lose 10% of the older mark. So yeah, there's no, in the exam, as long as the topic is part of the exam, you should study as much as you can. Yeah. It's very hard to predict how much it will come out. Some exams, in the actual methods and specialists, they will tell you, because they will tell you how many hours the teacher is supposed to spend on each of the different topics. right? And the number of hours there should correspond to how many marks are there in the exam.
In grade 12, like when I do my externals, is that tested on like the whole year, like
Yeah, unit 3 and 4.
3 and 4? Oh, okay.
And unit 3 and 4 stuff will have some stuff from unit 1 and 2 as well. It's like unit 1 and 2, you learn about vectors, polar form, vector projection. In unit 4, it's assumed that you know those ones.
Oh.
And so the question will just assume that when they mention projection, you know what it is.
Yeah.
So they don't explicitly ask like, oh, calculate the vector projection or calculate the polar form. No, they just throw it in the question. You're supposed to know it. Yeah. Okay, so addition multiplication principle. If there are n ways of performing operation A and m ways of operation B, then you multiply them when you're performing A and B.
Oh, I remember doing this.
Yeah?
Yeah.
Okay. And then when you add them is when you're performing A or B.
Yeah.
Right?
Yeah.
Okay. So let's have a look at some examples here. Okay, let's try this one. Okay, Janine's restaurant offers its patrons a choice of 3 entrees, 9 main courses, and 4 desserts. How many choices of 3-course meals are available? How would you do question A?
Is this combination?
No, this is before combination and permutations. So it's just either you add them or you multiply them.
Oh, multiply.
You multiply.
Yeah.
You sure? Why?
And
Add and multiply. You gotta tell me a reason. So is it?
it's like and, right?
Oh, you mean and?
Yeah.
Yes, that's right. Yes,
Yeah.
and. So it must be something and the main course and the dessert. So yes, it will be 3 by 9 by 4. Because for each entree, each entree like A, right?
Yeah.
You can choose 9 main courses. And each of the, let's say, main course M1, you can choose 4 desserts. So A, entree 1, main 1, and then it will be 4 desserts. Entree 1, main 2, 4 desserts.
Yeah.
Alright, so yeah, it's multiplication. So yeah, 12 by 9 is?
12 by 9 is 96. 108, 108, 108.
1?
108.
108, yeah. B, how many choices of entree and main course are offered?
Entree and main course. That's 27.
Yeah, 27, yeah, easy. How many choices of main course and desserts are offered?
That's 9 by 4. So that's 36.
36, okay. Question D. How many choices of 2 or 3-course meals are available? Assuming that a main course is always ordered.
This is add, right?
Yeah. But you're adding what?
2 or 3-course meals. Two or 3 course. So you can have like 3 and 9, or 9 and 4, or 4 and 3. So do I add all those together?
Wait. Main course is always ordered.
Oh, main course is always ordered. Okay. So that's 3, add 9, add 4.
No. 2 or 3 meals. But a 3-course meal, how many ways to choose a 3-course meal?
You have 108.
Correct.
So 108.
Mm-hmm.
And then add or do I have to multiply for the 2 course first and then add those 2 together?
Yep.
Oh, okay.
Okay. So
that's 27 and 36.
Yep.
27 add 36?
Yep.
Oh, okay.
Does it make sense?
Yeah.
Yeah. So you have to list out what are the or events, right? So it will be 3-course or 2-course entree main, or 2-course but main dessert, and that's why you have to do ABC first. Alright, so they give you a hint on question D. Yeah, so 3 course is 108 choices, and then this one will be 27 choices, and this 36 choices. So you add them together. Add them together.
Oh, 135 plus 136, 171.
Okay, good. 171. Okay. Yeah, I just like to throw my students to do mental math questions because it helps with the calculations. Okay, 171. All right. So yeah, so that's the addition and multiplication principle. Okay, and means you multiply, or means you add.
Yeah.
Okay. I think that's actually the majority though of combinatorics. And these one is just the applications.
Yeah.
Yeah. Okay, is that the last one? Applications and... You didn't learn this one, did you? Pascal's triangle.
Pascal's triangle. I think I remember being said, but just Pascal's triangle, not binomial theorem and pigeonhole.
Pigeonhole is specialist unit 1.
Oh. Okay.
That's a really cool one. You can find some YouTube videos on pigeonhole principle.
Yeah.
Yeah, you can learn that in advance. It's just for fun. But it's actually part of methods unit 1. So the applications one, I think it actually depends on your knowledge of the restrictions. Yeah, this one.
Oh.
Yeah, okay. Okay, maybe we have to go through this one after all. So, I think we went through... Yeah, okay. I'll explain a little bit about this one here. So, if the first group has n1 of indistinguishable things, which is like a letter A here,
Yeah.
right? And then the second group would have like, let's say, all the letter L's here is indistinguishable. It's the same thing,
Yeah.
right? So then when you calculate like the probability, it will be... Oh yeah, it's just Coon, the other shooter. It will be... Hey Coon. So 8 options in total.
Yeah.
And then divide by the parts that are non-distinguishable, which is the letter A that appeared twice, and then the letter L that appeared 3 times. Yeah, so just divide by 2 factorial, because some of them would have like, if you choose the letter A, it would be indistinguishable from each other. So you're dividing because you're taking them out, you're counting them as one thing.
Yeah.
Right? And there are 3 letter L's. Right, so that's why you also divide by 3 factorial, because when you pick any of those letter L's, it's the same thing.
Yeah. Okay.
Okay, so let's see. So that's why it's a factorial over 2 factorial times 3 factorial. Okay, same with this one here. 4 back 3 counters. So you start with the 7 factorial on top. Right, so normally it would be 7, but then 4 of them are the same, so you have to divide by 4 factorial.
Yeah.
And then 3 of them are also the same, so you also divide by 3 factorial. Okay. Do you have enough time? What time is it? Yes, we do have a little bit more time. All right, let's try an application questions of permutation combination.
Okay.
To be honest, I think combinatorics is one of those topics where it's pretty hard for students to get a hang of, but once you get a hang of it, you can get pretty good at it. But if you don't do it, you forget it again. It's one of those things. The other topics though, like that you will learn later in specialists, and like vectors and matrices, you can't forget about them. It makes too much sense, to be able to forget about them. So we'll see this one. 10 points are marked on the page, and no 3 of these points are in a straight line. How many triangles can be drawn joining these points? What do you think?
10 points, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
And no 3 points are in a straight line. So how many triangles? Okay, so remember, the key concepts are, see which one you remember. So first one will be addition or multiplication principles, right?
Yeah.
And then either is permutation or combination. And then you think about, is there any restrictions or, restrictions or like objects that you might have to deal with.
Page and nothing.
Right?
Is it combination?
Combination why?
Because like it's like you don't have to choose like specific
Order of the points.
Yeah, order.
Correct. It's combination. So it will be
10 C3.
yeah 10C3. Go back, work it out. Done. Question B.
How many different three-digit numbers can we make using the digits 1, 3, 5, 7, and 9 without repetition? It's multiplication. Combination?
Combination. So do the orders of the digit matter? Let's say we
No.
pick 3-digit number like 1, 3, and 5. Is this the same as?
Oh, it's not.
It's not the same, which means
So it's permutation.
it's permutation. Okay, and without repetition, so it would be.
So it can't be like 3, 3, 3, 5, 5, 5.
It can't be 2, 2, 5, 5. Yeah.
Yeah. Okay.
Which is it's just purely the permutation formula. Okay, so 5 and then permutate 3. 5p3.
Okay.
Okay,
Yeah.
because if you can pick with repetition, then the answer is basically very simple. It's just 5 times 5 times 5.
Oh. Yeah.
Right? Yeah, because I think that should be it.
There's a lot of things to like remember. What can I not do? What can I?
Yeah,
do?
what can you not do, right? Hang on. For permutation, the difference between permutation, because I'm thinking this one, how many different 3-digit numbers, right? The first digit, you can think of it as the first digit could be any of how many ways to choose the first digit out of this is 5 ways.
Yeah.
And how many ways to choose the second digit? That's 4 ways. And how many ways to choose the third digit? That's 3 ways.
Oh.
Right? So that'll be 5 by 4 by 3. Is that the same? I'm trying to remember. So 5p3 is going to be 5 factorial over 3 factorial times 2 factorial. Oh, well, sorry. Over 3 factorial, yeah. 5 minus 3 factorial, that's right. Right? So that will be 5 factorial over 2 factorial. So the top will be 2 factorial times 4 times 5 times 3 times 4 times 5. And then it will be 2 factorial. Oh yeah, same thing, that's right. Yeah,
Oh. Yeah.
it's permutation. Yeah. Sometimes I myself get confused with these questions. These combinatorics ones, very, very tricky. Okay. Next. Let's try one more. Alright. Jade and Kelly are 2 of the 10 members of a basketball squad. In how many ways can the team of 5 be chosen if both Jade and Kelly are in the 5?
Is that a restriction?
That's a restriction, yes.
Oh. Okay. How many ways can you do 5? Is this
It's like a combination.
It is combination?
Yes, because it doesn't matter, right? It doesn't matter in this team of 5.
Oh,
Mhm.
yeah. Okay. So it would be 10. No, 5. 10 members.
So question A, both of them must be in the 5. Which means, so you always deal with the restriction first.
Oh.
Which means, so the restriction, both Jade and Kelly must be in the 5, right? So the 5 would have Jade, Kelly, and 3 more. How many ways to choose 3 more?
3 factorial. 3 factorial.
No, it's 8C3.
Oh.
Does it make sense?
Yeah, because you minus 2 from 10.
Yeah, you minus 2 from 10. And then how many ways to choose 3 from out of the remaining 8?
Oh.
Okay, and because Jade and Kelly are in it, it's just there's only one option for them to be in it. So the answer is actually just 8C3.
Yeah.
Yeah? Okay? These are the tricky ones. Right? You have to practice these ones. Yeah, as I said, it's tricky when they start combining stuff together. Right? B, neither Jade nor Kelly is in the 5.
Do you have to minus it by 2 again?
Yep.
So is it 8 and then C?
See something.
Yeah. That's okay. 5?
Yeah, it's 8C5.
Yeah.
I think. Let me double check this. What chapter is this? Chapter 10. And then question C.
Jade is in the 5, but Kelly is not. Jade is in the 5. Kelly is. Would that be 9C? Oh, Jade is in the 5. J and 4 more.
Yep.
But Kelly isn't.
Mm-hmm.
So, what would the first number be?
So Jade is in, which means 4 more, right, out of 9. But this 9 has no Kelly. So it's not 9, it's 8.
Oh, okay.
Therefore,
8. C. 4.
yeah. Yeah, that's right.
Okay.
Make sense?
Yeah.
Yeah? Pretty okay, right?
Yeah.
Yeah? But please go back and practice this, like tonight or tomorrow.
Yeah.
Remember, the graph,
Yeah.
if you don't practice it, you're going to start forgetting, yeah?
Yeah.
You can ask me for questions anytime, right? But you should go back and practice. So far we've covered Surds with chapter 1 and then chapter 10.
Yeah.
Right? That's all of chapter 1 and 10 though. So pretty good progress, I think. Right, and the last question for me?
I know next term we have a PSMT on combinatorics and permutations.
Oh, which is this one?
Yeah.
Oh, yeah. Don't tell me it's one of those things where they ask you to design like a experiment.
Yeah, I saw in one of my friends on Stay High showed me that PSMT, and it was like a dice rolling thing where you have to like create something and use Excel.
My last specialist student,
Yeah.
he created a casino game using combinations and permutations. Combinatorics. A casino game. Got 20 out of 20. I can send you the assignment when the time comes. You need to see what your assignment is first, but this is really tricky. We did a lot of really intense
Yeah.
math.
Okay.
Yeah. But yes, should be okay. If you get all these combination, it should be okay.
Alright.
Yeah, so go back and practice this
Yeah.
one.
Okay.
Mm-hmm.
Is that it?
Yeah, that should be it for today.
Thank you.
Yeah, no worries. So yeah, so normally a lesson will have this much math, and I'll send you the recording.